Hi everyone, thanks very much for joining the webinar. We started a little bit late because we were just waiting for other people to join. But yeah, thanks a lot for joining. I'm Kay McGuinness and this is Nathan Lawrence.
Hiya.
Probably most of you know us already. We're also joined by Matt, our inside sales specialist. You can't see him, but he's controlling all the IT. So if it all goes wrong, we've got someone to blame. Okay, so we've got a few slides, not too many. But just a few. So I hope you can all see that okay. This is the agenda for the webinar. We're going to do a brief intro to tell you kind of how the sensor works, how it can possibly be calibration free, explain a bit of the transducer and the differences between our pH sensor to the traditional glass electrode, which most people are used to. And then we're going to go on to the demonstration. You can probably see the tanks in front of us. And we're going to demo from the connection of the sensor all the way through to the sensor output, and then also the utility program and the GUI. And then finally, we've got a discussion on it, how to integrate the sensor, the future plans, and how you can get more information and buy the sensor. Okay, so Nathan, did you want to explain how it works?
Yeah, I'll try to. So how does it work? So when we started A&B, we went to speak to end users, deployers of glass electrodes and manufacturers of glass electrodes to ask the question why calibration is required. Overwhelmingly, the response came back due to reference electrode changes in deployments. Air technology is unique in the fact that it monitors reference changes in real time in situ without end user intervention. We highlight a response here. Well, on a traditional glass electrode, after 10 hours, you see a change in pH. Is that change in pH really a change in the pH of the solution or a reference electrode change? We incorporate in our sensor a reference electrode tracker, shown in the red dots on the transducer. The transducer is the replaceable part of the sensor and is used to determine the pH of the solution. The reference tracker tracks the changes in the reference potential of the reference electrode. And you can see after 10 hours using our reference tracker, that's actually a change in the reference potential. We combine this measurement with the pH monitoring electrodes on the front surface of the transducer. And by combining the two measurements, we get a calibration-free sensor. This allows us to give specs around pH range 2 to 10, resolution of 0.01 and accuracy of 0.05. The sensor on the B9 firmware that's released on the website covers the range 0.3 to 40 ppt salinity, and the temperature sensor has a 0.1 degrees C accuracy. The unique advantage of our reference tracker is it also outputs salinity as a direct measurement and conductivity as a mathematical calculation from the salinity measurement, making us a calibration-free salinity, conductivity, temperature, and of course pH sensor, and it never needs calibrating.
Perfect, thank you. Okay, so that's how it works and why it's calibration free. And now we're going to go on to demonstrate the sensor. So if you could show like the connection and the different types.
Yeah. So first off,
carry on, it's okay.
So first, I'll just tell you why we're different to a glass electrode. So all our sensors are solid state, they're robust, they can be stored wet or dry, can be dropped easily, they won't smash, and they're very robust. They're smart as well, giving intelligent monitoring of what's happening inside the sensor in real time. We have various ranges of the sensor depending on the depth of deployment, from our 1250 titanium version, 300 and our 5 and 50 meter range. The key difference in the 5 and 50 to the 300 and 1250 is the termination. 5 and 50 are normally pigtail terminated for easy screwing into terminal telemetry systems. The OC300 is subcon connected. It's a 6-pin connection on all of their sensors, 2 for power, 2 for 232, and 2 for 485. Easily instructions on the website as to which pin connects to which. In our demonstration today, we're going to hook it up to our data transfer unit so we can actually talk to the sensor through a laptop. Obviously, if you have your own telemetry system, digital telemetry system, 232 or 485, you can do this yourself. But today we're going to use our data transfer unit, which is available on our sales channels. We simply plug the sensor into the USB, into the subcon connector. We then turn on the data transfer unit. This is talking 232 to the USB port of the computer that Kay has, and is also powered through the USB port of the sensor.
Cool. I think you forgot to mention the cable if it's pigtailed.
Oh yes, sorry. So if this is pigtailed, obviously this is a different connection. For those pigtailed customers and want to talk to it for a DTU, we offer a converter kit, which is a DIN connector with a chocolate block on the end, and this easily plugs on the end of the sensor using the chocolate block termination. Again, there's instructions on the website on how to do this.
Perfect. Okay, so now the sensor's connected. I'm going to show you how to communicate with it through our A&B utils. So this is a utility program. It's a terminal that you can download, a terminal program you can download from our website free of charge. When you open it, you get a landing page like this, which shows all the COM ports on your computer. Which one did you plug me in? 6?
6, yeah.
So I need COM 6, so I'm going to choose port 3. And here it finds the COM port, and it automatically finds the baud rate that the sensor is running at. Then it comes out, once it's found the sensor, it gives you the information on the type of sensor, the serial number, and the firmware versions that it's running. And then it gives you 3 options. So you can install new firmware, download the data from the sensor, or open a command line prompt. So the idea of this is that it's just really easy and intuitive. And if you want to install new firmware, you just select option 1 and then go through the stages. It asks you a series of questions, and you just reply to the questions, and it does it automatically upgrades your sensor with new firmware. So it also takes the new firmware straight from our website, so you don't have to worry about downloading it from there anymore. So it really is, hopefully, easy to use. We've had really good feedback on this utils program. But now I'm going to show you option 3, the command line prompt, because we want to access the sensor menus. So when you click on 3, you get the splash screen come up, which gives you more information about the sensor. And as you can see here, the date and time are currently set at 0. So the utils program automatically sets the sensor's date and time to the current date and time of your laptop. So that does it automatically. You just need to wait a minute or 2. So once you've got that, you can type menu to access all the menu functions of the sensor. And here they are. So we have 3 different kind of types of functions. We have system functions, measurement functions, and data functions. And simply by typing the function there that's in capital letters will give you access to the kind of option on the sensor. And then it is hopefully very intuitive to turn on and off things or to change things. You just follow the questions that it asks you. So if we just go through these line by line, if you type version, it gives you that splash screen that you can see at the top already, so we don't need to do that. If you type time, you can change the date and time of the sensor. If you type mode, which we'll do, you can change between controlled and autonomous operational modes. So I'll type mode in there, and you can see it gives you an option. So maybe, Nathan, you can talk a bit more about these?
Yeah, so the difference between these is, one, manually controlled is where you're on a telemetry platform and you can send a scan command so that you can control the sensor in real time. Autonomous mode is where you can set interval and start delays. You can hook the sensor to a battery pack or remote battery system, have a start delay, and it will start monitoring as soon as the time's up and it starts to go. You don't need any end user intervention for this. It does it completely automatically. And that's the 2 key differences between the controlled and autonomous system.
Perfect. Okay. So we have lots of customers that use the autonomous mode, don't we?
Yeah.
Okay, so if we'll keep in manual for now and go back to the menu and we'll carry on going through these. So that was mode, switching between controlled and autonomous. We can go to baud, where we can change the baud rate.
Yeah, so this is just all around your data rate speed from the sensor to your device. We go anything from 9600 to 11500. From a factory setting, the baud rate set at 57,600, as Kay showed you earlier. When we booted up utils, it found 57,600, but this is completely user configurable depending on your own integration system. And we have customers using anything from 9,600 up to 11,500.
Perfect. So the next function is interface. So this is to change, I'll type it in so you can see, but this is to change between Modbus or keyboard communication. So maybe you can say a bit more about that. There's lots of Modbus
There is.
info, isn't
There's
there?
loads of Modbus info. So there's lots of Modbus info on the website, giving you all the Modbus command protocols for all the terminal protocols that we have. It's completely configurable. We've integrated it into a number of 485 Modbus telemetry platforms now. I would say this is a really big improvement we've made during the course of 2024, working with telemetry platform integrators and updating their Modbus protocols. So it's really easy to integrate now.
Perfect. I'll keep on terminal mode. One thing to say is that if you are in Modbus mode, when you open utils, it automatically switches out, doesn't it?
Yeah, so obviously there is a way that you can return to telemetry through from a Modbus system by sending a #702 command to the sensor. Utils does that automatically when you turn it on and sends a #702 and takes it out of Modbus mode. So you can then come back to the terminal mode interface.
You can also change the Modbus address from that function there,
Yeah.
the underscore address if you want to.
Yeah, so all the sensors are currently have a Modbus address of either 55 if you already have one, or there'll be the last 2 digits of the serial number. Obviously, if there's a conflict with pre-existing sensors on your Modbus system, this can be easily changed using the Modbus underscore address protocol.
Yeah, so actually that reminds me about the serial number. You can find the serial number on the splash screen by typing version, but it is actually now on the sensors.
It is displayed on the sensor on a label, which you probably can't see on that resolution, but they all carry the labeling now on the sensor.
Perfect. Okay, so if we're going to move on to measurement functions now, and the first one is immersion, so I'll just type that in to show you. But basically, all the sensors now have an immersion sensor on. So the sensor won't start scanning until the front surface of the transducer is immersed, which is really good, really handy for when you first have it and you want to kind of check the comms on the lab bench. You can disable the immersion sensor and check the comms, otherwise it just keeps beeping at you. But yes, also got other uses.
Yeah. So we've got customers now that are using this to test not only to sensor deploy, but the whole telemetry platform and a multi-parameter system, where they drop the sensor in. Is it immersed? Do they turn on the whole telemetry platform to start doing a multi-parameter measurement, or do they just wait until it becomes immersed? So this is a really good way of just checking that, not just a sensor, but other systems and sensors that you might be deploying as well, just to save power. It's done immediately when you send a scan command or when it starts measuring, and it does it straight away, and it will shut itself down if it's not immersed, and then repeat that check at a preset level.
What about that riverbed customer?
Yeah, so we've had people who have deployed it in sort of estuarine environments where they're looking at dry wet monitoring. So of course the tide goes out and comes in, so it stops monitoring when the tide goes out, and then come back in when the tide comes back in, it starts monitoring again, saving power for remote platform deployments.
And kind of storm drain applications and this type of things, isn't it?
Yeah.
So I'll keep that on for now, but that's the immersion sensor. Interval is the next one, and that's so you can set a time delay between the measurements. If we check on this now, if I can spell it right, if you leave it at 000, that's continuous monitoring, and then you can go from between 15 minutes to 240-minute intervals. So we'll put it on continuous, but I don't know if you can.
No, so when it goes to sleep for the wait time, the sensor goes to sleep, so it goes into its lower power mode. So that's just around saving battery.
Yeah, we've had lots of discussions with customers about saving battery in low power mode, haven't we?
Yeah.
This is kind of future plans.
Yes.
But we're doing all we can to lower the power.
Yeah.
So next, after interval, we've got the scan functions. So we've got, at the moment, we've got a scan O and a scan F, which is a salinity cutoff. So scan O is a high salinity, scan F is a lower salinity. And we've also got, as you can see, an O1 and an F1. So that's if you want to do just get a single result back and then turn the sensor off. Again, this is the low power application, isn't it?
And we've got customers now that have written terminal programs where they send a scan, turn the sensor on, send a scan 01 command, wait for the pH to be returned. Once the pH returned, they just shut down the sensor, so it saves power on their whole measurement system.
Okay. So yes, if I type scanno now, the sensor will just start scanning, and I won't do that because it's just on the bench. But these two, the other two sensors we've got in tanks are scanning now. So the last measurement functions are stop and shut down, which really just speak for themselves. And then we have the data function, which is type in results, which I can do now. You'll see it gives you a list of all the files. So each sensor contains an SD card inside, which saves all the data in CSV format, which you can access from either here from the menu, or if you remember from the beginning, when you open utils, one of the options is to find the results and download the data, so you can get it from there too. But hopefully you can see it's really straightforward to use, really intuitive. So that's good. Okay, so I'm going to stop sharing now. And we can look at some of the data coming from the sensor.
Yeah. So where Kay's doing that, so output string is fixed across the sensor range, providing you all the data that you require in both the ocean and freshwater scanning modes. Can we share that one?
Yeah.
So in this setup here, we have a freshwater tank and we have a high salinity tank, and we're monitoring these continually as we're going along. This is coming from our ocean sort of high salinity tank. Now our salinity sensor will only work up to 7 ppt, and that's why you won't see any salinity or conductivity outputs here. If we look at the data stream, we have a $A and B identifying its an A and B sensor and a checksum. We then have the date and the time the measurement was taken. We have the pH, the solution, we have the temperature. The 99.99s that you can see there are our default salinity and conductivity numbers for the ocean measurement, as it's outside of their 7 ppt range. The 2 zeros are around transducer and sensor diagnostics. We'll talk about those in a bit. That 0 there is basically a reserve byte. If we improve or include extra functionality to the sensor through firmware updates going forward, there will be then a number output in this one. The 55 is a nice reminder of the Modbus address of the sensor. And then the last number, the 20, is the file which all the data is currently being saved to.
Perfect. So we can now maybe have a closer look at the health number and the sensor diagnostic number.
Yes, let's do that.
So this really sets us apart from the glass electrode, doesn't it? Really,
it does, yeah.
Getting feedback from the sensor onto how it's performing.
Yeah.
So we've had some horror stories on the glass electrode where they've had data coming back, lots of data coming back, and it all seemed fine. But when they went there, it was actually broken, wasn't it?
Yeah, exactly. So everything appeared well, but it wasn't actually working properly. So the sensor's smart in the way that it looks at the sort of the raw analog signals that it receives, and interprets those signals to give us the sensor diagnostics. On the website, we have the sensor diagnostics table, which is shown here on the sensor output page.
It's worth just mentioning, I think you said before, but if there's any kind of default error or no number, then it comes out as a 99.9.
Yeah.
On our sensor. But here's the transducer health table.
Yeah, so we set a transducer health range from 0 to 6. Those outputs are shown here and their meanings and actions required. Obviously 0, no action required, the sensor is working healthily. And thankfully for these two sensors working here, they're both 0. The 1s and 2 require some abrasion, and I'll talk about how we do abrasion soon. And 3 is a replacing of the sensor. The 4 is really interesting because it's the immersion detect sign. So as I say, when you turn on the sensor, it does an immersion check. If it is not immersed, then a 4 will be immediately returned in the transducer health number, and the sensor will go into sleep mode. So it's an immediate response to whatever scenario is occurring in front of it.
So now it's a good bit. Do you want to do the abrasion?
Exactly. There's a much better video on the website, and so we'll show you that, where you can see that on the website. But the abrasion is really quite simple. All we do is get a piece of sandpaper, which comes with the sensor package. We have the transducer, we have the top face of the transducer, there's some recessed parts on the transducer. We take a Sharpie, we mark 2 dots on the top of the transducer, and then we take a abrasion block and simply abrade the surface like that until the Sharpie points have disappeared. And that's really all there is to it. It can be done either on a bench, in a ship, or actually underwater in deployment. So we have customers that have sent down divers and done this underwater with a diver. And also you can think in the future about putting on an abrasion system, similar to having a wiper on an optical based sensor. You can make that a more abrasive system and just simply abrade the surface. So that's something that could be done by remote deployers and easily done as well.
What about how often you need to do it?
Yeah, so how often we do it really depends on the use case. Typically, it's around 15,000 measurements before we have to do an abrasion. That equates to 5 days in continuous monitoring, 52 days or 54 days every 15-minute intervals, and around 200 days on hour measurement frequencies. That's given by your health 1 or 2. There's also the health output of 3, which is transducer replacement. That transducer replacement occurs after around 20 abrasions. So for 1 hour lifetime, you're looking at quite a few years of deployment there before a transducer requires a replacement. Transducer replacement is simple and easy. There's no calibration required for this. You take your sensor, there's a clip on the top which is screwed down. In this case, I've taken away the screws just to make it slightly quicker. You can slip the clip off. You get your bottle opener, which again comes as your maintenance kit. It's not just for opening your beer.
It's not a bottle opener, it's a transducer replacement.
Transducer replacement tool, shall we call it? And you just simply prise the transducer from the sensor itself. Just takes a little bit of force just to pull the transducer out, and that's it, really. You then get your replacement transducer, which I'll grab from over here. You just line up the key, and then you just slide it home easily enough. And that's it. And it's good to go again. Again, no calibration on the transducer replacement. They're all made in the factory here, and they're all identical in their manufacturer. They're all checked and verified before we send them out that they fit the calibration within the sensor. So there's nothing you have to do other than pop it out and push one in.
There's videos of those 2 processes on the website where they use proper grease and everything. They do it properly. So yeah, maybe have a look at those. Yeah. But it's straightforward to do. Brilliant. So next is the GUI. So we've made a user interface for the customers based on feedback really from our customers. This is free of charge and it can be downloaded from our website. So if you go to the support section and GUI, you can get the demonstration video and the download link. Once you've downloaded it, you just unzip it, put it on your desktop, and then you're ready to go. And here is the GUI. Just move this out of the way. Here's the GUI running in the freshwater tank. So we have, once you select the COM port, and then it gives you your sensor details there, like on the splash screen of utils. And you have some options here, which I'll go through. This first bar gives you the status of the sensor, so how the transducer is doing and how the sensor is doing, and that's basically the health number, the transducer health number that Nathan went through before. And then we have all our plots. We have pH, temperature, salinity, and conductivity. And this can be changed around. The settings can be changed on the user interface based on what you want. So I'll just quickly go through these buttons. We have the sensor settings, where you can change the time and the date, and you can change the measurement interval. So we're on continuous at the moment, but you can change between the 15 minutes and the 240-minute intervals from here. This button here changes the settings on the user interface, so you can choose which plots you want to see, which are interesting to you. You can also set limits. So here, for example, we've got a lower limit of 6 and an upper limit of 9 for our pH. We haven't set any limits for temperature. And you'll see here, so then see the green lines, there are limits. And if it goes outside of those lines, then you get this little alert here. tells you, in this case, the temperature is outside your predefined limits. So hopefully it's a really visual way, a really quick way of seeing if you know your metrics are kind of outside the range you want them to be. You can zoom in on the pH chart, which zooms everything, and zoom back out here. Again, hopefully really easy to use, really straightforward. This one gives you the log output, so that's the data stream there. And then you have the stop and shut down and start, which speak for themselves. But yeah, so this is our user interface, really easy to use, really straightforward, and free of charge from our website. What I forgot to mention before actually is when you use the A&B utils, which you also just download from the website, it creates a log file. And in that log file, you'll find all the sensor output, just like I showed you here. So you can look back into the utils log file at all the data, which is quite handy sometimes. Okay, so that's the GUI. So I think that sums up really the sensor. Maybe you can talk about the other bits that go with it.
So as Kay said, the utils and the GUI is free of charge. We do have chargeable accessories too. We have a data transfer unit. As I say, it's a way of just talking to the sensor through the USB port of a computer and making it easy to configure the sensor. And you only have to buy one of these per batch of sensors. You don't need to buy one of these per sensor. But you can put multiple of these onto the same computer easily enough. We have a flow cup for putting the sensor into a flow situation. Simply unscrew the lid, pop the sensor in, close it back down. This is rated to around 10 psi on the flow adapter, so that's quite easy to use and install. We also have an intelligent battery monitoring pack. So this takes the lithium-ion battery, looks at the rechargeable voltage of that lithium-ion battery, so that it will understand the voltage of the battery, make sure it doesn't go below the recharge voltage, and control the sensor in a way that is stable. It's a low power way of controlling the sensor. We've halved the power consumption of the sensor using this IBM that we like to call it. All the data from the sensor is also stored on the IBM through an SD card for easy data retrieval. And if you're looking at monitoring every 15 minutes on a sort of a 28 amp hour battery, you'll get around 60 days of usage. You can multiplex up your battery packs and it'll control both of those. So you can get 120 days of use on a 15-minute battery, 15-minute monitoring interval using the IBM. And as I say, all the data is stored on the IBM on an SD card, easy to remove after deployment and download onto a computer.
Perfect. Okay. So just finish off with a few more slides. I think I forgot to say at the beginning, if you've got any questions, please type them in the Q&A. Did I forget to say that at the beginning? Please type them in the Q&A and we'll get to them at the end. But here's just a few more slides to show you some integration work we've done. Oops.
So we've obviously been going a while, and some of you guys know about us for a while. We've done a number of tests and deployments now, and we're really quite pleased with the progress we've made, especially over the last sort of 18 months. I think that although we've been on different platforms, the one I really want to highlight is the top right there, which is our anti-biofouling measure, which is a natural byproduct of the sensor. We did some tests in Barcelona where we deployed two sensors. The one on the right-hand side, you can see there's a lot of biofouling incrustations on that surface. That wasn't actually switched on during the deployment. It was a control sensor. The one on the left, we actually had switched on the monitoring. You can see there's no biofouling on the front surface of that sensor. And that's because we generate a small amount of peroxide during deployment. And that peroxide is enough to keep the transducer surface clean from the biofouling. Obviously, it's a peroxide, it breaks down quickly in water, and therefore isn't a long-term contaminant of the solution. We've also come quite far now on the integration of the sensor. We've integrated onto multiple platforms. With Alzheimer, we have it on the Alcon AUV, and it's currently looking at CO2 expulsion from underwater volcanoes. With EWS, a telemetry platform in Australia, they've integrated it through a 485 Modbus communication protocol, quite easy now. C-Signal was through a 232 terminal communication. This is a completely wireless telemetry unit, which you can deploy underwater. All data through the C-Signal package is transferred wirelessly to a surface, and the sensor is easily connected to the underwater platform. We've deployed it on an EcoSub mini AUV there, easily integratable through their 232 program. Metasphere, another 485 Modbus protocol, and we also now have data outputs for a slope and glider on the current release firmware version 9, which mimics the output of an previously integrated CO2 sensor. And then instead of producing CO2, we output pH where you might see that. So this makes it really easy to integrate it onto slope and gliders now.
Yeah, so I think the take-home message here really that we'd like to give you is that it's really easy to integrate into any system.
Yeah.
We've done it lots of times in lots of different ways. There's never a problem too difficult, is there?
No, exactly.
That 500 web meetings don't solve.
Exactly. And that's it. Reach out to us if you do have any questions around the integration. We're always willing to help. We can always send an adapted firmware to help the integration if there are issues, but we've actually put it into a multiple different output platforms now on the digital comms 485 Modbus terminal systems.
Okay, so where next for the sensor? So the good news is that all our kind of upgrades are done via firmware, which, as you've seen, is very easy to do. The customer does it themselves through the utility program. They go on our website, we tell the customers, and then you can easily upgrade your sensor. So the next ones that are planned, that are actually coming very soon, are a lower salinity operation. Yeah. So do you want to talk about that?
So currently our cutoff is now 0.3 ppt. In the next 3 weeks, we're releasing a firmware that takes it down to 100 microsiemens per centimeter conductivity, around 0.05 ppt. So that's a good step forward. Within that firmware, there'll be a profiling mode to give a quicker response change to pH changes within a solution, which is really good for profiling customers. One of the unique things of the sensor is a reference checking system to make it calibration free. While the sensor is doing its reference check, there is a downtime and that it can deliver pH. Obviously, this is consuming power for our customers. We've shortened that down in the next release version to make that speed quicker, and we're always looking at ways to improve that through further firmware iterations. We understand that customers, whether working in variable salinities across their threshold, will not like the O and F scan routines. So part of what we do is actually make it a single scan command, which make it much easier to deploy. So that's something that we're looking at. Currently, all our sensors are only bootloadable through 232 digital comms. We will be releasing in the coming months a 485 bootloader, so allow that to be done for our 485 customers. So that's on there as well.
Okay, I don't know if that's on the screen, Matt. Can you maybe move it to the side? I can't see that from here. Perfect. Okay, so where can you get more information? The website, hopefully everybody's seen the website. I showed you before the support pages where you can get the frequently asked questions, the download of the GUI, and then the user guides. And the user guide, this documentation has the AMB utils download and all the information you could possibly want about the sensor and its operation. But of course, please email us if you've got any questions and you can't find them on the website. And then the question I'm sure you're all asking is, how can you buy the sensor? So also on our webpage, we have a sales tab. You can contact us directly for sales, or you can look for your country in the list, and there you'll have a list of distributors and resellers for each country. So hopefully it'll be really easy to find one of our lovely partners who can help you. And really, that concludes, I think, everything apart from the bits we missed out. But everything we wanted to tell you.
Yeah, so this just summarises really what the sensor's about. So it is calibration-free pH, temperature, salinity, and conductivity. So therefore, it is a sort of a multi-parameter single-shot sensor, which is in a small, robust form factor. Within that sensor, you do have your anti-biofouling measurements. It's a natural byproduct of the way that we do the measurement. It is easy to use, very much plug and play, which is the way we want it to be, and integratable, integrating friendly. And we are working on lowering that salinity range so we can get the whole salinity range from really 0.05 is our next cutoff up to 40 ppt salinity. easy to store, no need to store it wet, dry or wet is fine, and it's adaptable and easy to put on there. It's also intelligent with its health output, really trying to provide the end user or the customers what's happening to the sensor, so you know what's happening and what's happening to the data that's coming back from the sensor.
Perfect. Thanks a lot. I think that concludes what we wanted to tell you. So maybe we can have a look at the questions. Let me stop sharing so you can see us better. Okay, perfect. Shall I read them out? Is that the best way? Do you want to read them out, Matt?
Yeah, can do. So the first one, may I ask if it has an internal pressure, temperature and salinity sensor, how can the data then be corrected for those parameters?
Cool. So it doesn't carry pressure at the moment. So that's not something that's really on our roadmap. We recommend putting an external pressure measurement on it. It has salinity measurement on it. The pH output is corrected for any salinity changes through the internal algorithms of the sensor. So the measurements ask about T90. So the response time of the sensor, we do a reference check, which is roughly around 1 to 2 minutes at the moment, depending if it's in ocean or freshwater monitoring mode, and then it outputs pH measurements every 17 to 25 seconds, again, depending on if it's in ocean or freshwater mode. To get to freshwater, we have to run the sensor slightly lower, just to make sure that we can get good signal to noise resolution and what we want. In terms of lifetime, every 15,000 measurements requires an abrasion. The sensor is smart; it will tell you if it needs an abrasion. So that's how you deploy it. The transducer depends on the use case. You can get around 20 abrasions per transducer replacement. So you get a large number of data points per transducer replacement.
Yeah, so for example, if you're scanning once an hour, you need to abrade the transducer around every 200 days, roughly 210 days. And then 20 abrasions again. So if you're scanning once an hour, it's kind of ages, 4,000 days before you need to replace the transducer.
That's a long old time.
So yeah.
Next question. Is the 0.3 ppt a hard low end cutoff for measurement? Have measurements been made in streams of lower salinity?
Yeah. So our current release firmware version 9 does have a 0.3 ppt cutoff. As I said, we are working on a lower salinity version now, which is due to release in 3 weeks, looking at around 0.05 ppt. We've had that running with a number of trial customers where we've had operation below that cutoff range. So yeah, so that's something that we're actively working on, and should be releasing the next 3 weeks to get that lower. And then we'll see where we're at. We know we can get lower again still, and then it's all work around having enough resources really to work on calibration algorithms for the sort of the 20 to 50 microsiemens centimeter, which is where we're looking to go past the next release.
Next one. What is the scale of the measured pH? Which reference system are you using for reference pH measurements?
Yeah, so all our sensors are calibrated against a glass calibrated glass pH probe using an IUPAC standard pH.
And then the last one, when do you expect the lowest salinity range will be available?
Yeah, so as I just said, we're looking at release of the 100 microsiemens per centimeter release in the next 3 weeks. And then beyond that, we'll give you an estimate on that timeline once we've released that one out. We say 100 microsiemens per centimeter now. It may be lower once we get to the release.
Well, talking about releases, do you want to say something about lead times?
Yep, so we're currently looking at an 8-week lead time on the sensors from point of order. So once the PO's in, it's around an 8-week lead time. We are looking at doing PCB board runs. Obviously, we've been sort of, as a startup, we manage our resources carefully in terms of the stock suite that we carry, and we're looking around an 8-week lead time at the moment, and doing future PCB board orders based on need.
Perfect.
And warranty? Do we want to mention warranty?
Warranty, yeah. Yeah, so all the sensors carry a warranty. So it's a 24-month warranty on the actual sensor and the DTU, and also the flow cup. For the transducer, it's a little bit different. It's either 10,000 scans or 90 days. So, and the battery pack's 12-month warranty. Brilliant. No, I think that's. If there's any more questions, if anybody wants to ask anything else. But no, I think that's everything.
That's great.
Thank you very much. Thank you for joining. I hope you found it informative. We're very happy to have meetings with anybody. If you need more information or want to get in touch, please do so. We'd be happy to hear from you.
Thanks
very
everyone.
much.
Cheers.